Millions of years ago, before it froze into Earth's southern icebox, Antarctica was alive. A land of warm rivers, whispering forests, and thunderous beasts beneath the dancing auroras, a green Eden at the bottom of the world. Today we journey back in time to uncover the lost world of ancient Antarctica and ask, what buried this paradise beneath miles of ice, and what warnings does it whisper to us now? Echoes of Gondwana, Antarctica's forgotten soul. Before Antarctica became a symbol of icy desolation, it was the pulsing green heart of Gondwana, an amalgam of continents that incorporated South America, Africa, Arabia, Madagascar, India, Australia, New Zealand, and Antarctica. Scientists think that Gondwana formed around 600 to 500 million years ago, when large pieces of Earth's crust, called the tectonic plates, collided and built huge mountain ranges comparable to today's Himalayas and Alps. Around 300 million years ago, during the late Paleozoic era, this southern landmass was not cloaked in snow, but carpeted in forests. The climate was humid and temperate, with rain-soaked air and year-round warmth. Forests thrived here, dominated by Glossopteris, a genus of seed ferns with broad, flat leaves that rustled like silk in the breeze. These towering plants formed thick canopies that bathed the forest floor in twilight. Beneath them, life flourished. Lumbering between roots and swamps was Lystrosaurus, a tusked, pig-sized creature with a beaked mouth and stocky build. A symbol of resilience, it would survive not one but two mass extinctions. Nearby, temnospondals swam in murky waters, large amphibians with wide, flat skulls and powerful jaws, relics of an amphibian golden age. Insects buzzed above in dazzling diversity, including dragonflies with wingspans stretching 2 feet. This was no frozen graveyard. It was a land of mist, sunlight, and growth. Yet deep beneath its forest floor, tectonic tensions brewed. The Great Dying, survival in the ashes. Around 252 million years ago, disaster struck. Vast volcanic eruptions in what is now Siberia released immense quantities of carbon dioxide and toxic gases into the atmosphere. The resulting greenhouse effect warmed oceans, halted currents, and turned seas into acidic traps. This was the Permian-Triassic extinction event, the most catastrophic extinction in Earth's history. Some 95% of marine species and 70% of terrestrial vertebrates vanished. Forests collapsed, coral reefs disintegrated, oxygen levels plummeted. Yet even in Antarctica's corner of Gondwana, life found a way. Fossils in the transantarctic mountains reveal bone beds of Lystrosaurus, a small plant-eating dinosaur living around 260 million to 240 million years ago, and its first fossil was discovered by a missionary in 1867. Lystrosaurus was a strange-looking beast and had a face only a mother could love. It was the size of a pig, weighing around 200 pounds, with no fur and a very unattractive face. It not only survived, but became one of the most widespread land vertebrates of the early Triassic. Its success came from simplicity, a low-slung body, sturdy legs, and a generalist diet. It rooted through the ruins of its world and endured. Before the extinction event, Lystrosaurus lived for about 13 years, but after the extinction event, paleontologists found that they lived only 2 to 3 years. They also decreased in size to that of dogs, but they were still spreading. This new paper concludes that that's because they started reproducing earlier and more often than normal in the face of extinction, which allowed them to boost their numbers while other animals slowly died out, unable to keep up. Antarctica, a lost world from Gondwana's legacy. After the Permian-Triassic extinction, known as the Great Dying, some 252 million years ago, life on Earth nearly vanished. Approximately 90% of marine species and 70% of terrestrial vertebrates perished. In the wake of this catastrophe, Gondwana, the southern supercontinent, underwent dramatic ecological and geological transformations. Its vast landscapes, once home to lush Glossopteris forests, became increasingly arid under the strain of volcanic activity and greenhouse warming. The Siberian traps released massive amounts of CO2, pushing Earth into a prolonged period of climate instability. recovery was slow. For nearly 5 million years, life teetered on the edge, surviving on nutrient-poor soils and enduring extreme seasonal shifts. Yet survivors emerged. Lystrosaurus, a squat herbivorous therapsid, became one of the most dominant land animals of the early Triassic. Dicroidium seed ferns flourished in drier conditions, while river systems supported early archosaurs, the ancestors of crocodiles and dinosaurs. Slowly, life began to reclaim Gondwana. By the Middle Triassic, 247 million years ago, ecosystems diversified. Conifers and cycads replaced the earlier seed ferns, forming denser forests across Australia and Antarctica. Amphibians like Brumastega thrived in the wetlands of the Karoo Basin, while primitive dinosaurs such as Euraptor began to roam the landmasses of what is now South America. Meanwhile, marine recovery lagged behind, but eventually brought back shelled organisms like clams and ammonites to the coastal waters of Gondwana. Driven by tectonic forces and convection currents in the mantle, Gondwana began its slow southward drift. During the Triassic and Jurassic periods, this movement altered climates and redrew ecosystems. Central Antarctica developed seasonal ice, while arid deserts expanded across regions that are now Africa and Australia. The opening of the Tethys Ocean altered ocean circulation patterns, introducing monsoon-like rainfall along Gondwana's northern margins and further isolating flora and fauna, leading to distinct endemic species. Around 180 million years ago, the supercontinent began to crack and fragment. The Earth split like the surface of an old painting. This breakup marked the beginning of the end for Gondwana. Yet it also birthed the continents we know today, each carrying remnants of a shared past. India broke free and drifted northward, colliding with Asia and bringing Gondwanan flora like eucalyptus into new habitats. Australia and South America preserved their marsupial lineages, and Antarctica, now isolated and cold, continued its silent journey toward the South Pole. Even as Antarctica moved southward, dragging with it ancient rainforests and river systems, life persisted. During the Cretaceous period, about 100 million years ago, the continent remained surprisingly vibrant. Fossils reveal that southern beech trees, Nothofagus, conifers and cycads still blanketed the land, adapted to the unique polar conditions of months-long daylight, followed by extended darkness. Within these twilight forests, dinosaurs thrived. Cryolophosaurus, a 20-foot-long predator with a bizarre, crest-like ornament atop its head, stalked the undergrowth, its flamboyant crown still a mystery to paleontologists. Was it for display, thermoregulation, or species recognition? Alongside it lived herbivorous dinosaurs like Trinosaura, the armored Antarctopelta, and duck-billed hadrosaurs. Their fossils, often found in ancient coastal deposits, suggest that the surrounding seas teemed with life, from graceful plesiosaurs to swirling ammonites. But this ancient world would not last. By the Oligocene epoch, 34 million years ago, full glaciation had taken hold. Ice sheets spread across the continent, wiping out much of the terrestrial life that had once clung on through cycles of extinction, adaptation, and migration. Antarctica became the frozen desert we know today. Still, embedded in its rocks and ice are the stories of Gondwana, of survival, resilience, and lost ecosystems that once flourished in warmth and twilight at the bottom of the world. The icy guillotine, how the freeze began. The warm rain of Gondwana could not last forever. Around 34 million years ago, the Earth changed. South America finally detached from Antarctica, and a deep oceanic rift opened between them, the Drake Passage. Through it flowed the Antarctic Circumpolar Current, ACC, a powerful clockwise moving current that effectively isolated Antarctica from the warmth of equatorial oceans. This event was pivotal. With the ACC in place, warm waters could no longer reach the continent. Combined with a global drop in atmospheric CO2, partly driven by increased weathering of rising mountain ranges like the Himalayas, Antarctica began to freeze. This marked the beginning of the establishment of the modern Antarctic ice sheet. As the continent became thermally isolated and greenhouse gas levels continued to fall, small glaciers coalesced into a continental ice sheet. Over the next 15 to 20 million years, the ice thickened and spread. By around 15 million years ago, Antarctica was nearly fully glaciated. The interior became a frozen plateau, and the massive East and West Antarctic ice sheets began to resemble their modern form. During the Quaternary period, the last 2.5 million years, these ice sheets were further stabilized by repeated glacial and interglacial cycles, locked in by Earth's orbital rhythms. The transition was dramatic. Glaciers carved valleys and silenced rivers. Forests, unable to adapt to the sudden plunge in temperatures, died en masse. Some leaves, like those of Nothothophagus, froze mid-growth, their cellular structures preserved like pressed flowers. By 15 million years ago, even the mosses that had once clung to volcanic rocks and coastal cliffs had disappeared from the interior. Only the coastlines retained small pockets of warmth, sustained briefly by geothermal heat. Whispers beneath the ice, the forgotten rainforests and living secrets of Antarctica. Today, Antarctica is a vast frozen desert, cloaked in 2 miles of ice and silence. But beneath this icy veil lies a world long forgotten, one of warmth, forests, and astonishing resilience. By the mid-Cretaceous period, about 90 million years ago, Antarctica was not a land of ice, but of green. In 2016, sediment cores drilled from beneath the Ross Ice Shelf revealed fossilized pollen, silent spores from an ancient swampy rainforest. Summer temperatures then averaged around 54 degrees Fahrenheit, 12 degrees Celsius, with winters mild enough to support diverse plant life, including ferns, mosses, and towering conifers. These plants thrived despite months of polar darkness, adapting by slowing their growth in winter and bursting to life under the 24-hour summer sun. Further evidence surfaced in 2023 when a team exploring Shackleton Glacier unearthed a fossilized tree stump, still rooted in place. The tree had once stood tall in a polar forest, enduring cycles of darkness and light. Its very existence rewrites our assumptions. Antarctica was not always inhospitable. It was once alive, teeming with forests, rivers, and creatures. And it wasn't just the surface that harbored life. Hidden beneath Antarctica's ice sheets lie subglacial lakes like Vostok and Mercer, isolated for millions of years. Within them, scientists have discovered entire microbial ecosystems that survive without sunlight, feeding on minerals through chemosynthesis. These ancient microbes mirror the kind of life we hope to find on icy worlds like Jupiter's Europa or Saturn's Enceladus. Even today, in total darkness and under immense pressure, life persists. But time did not stand still. Around 35 million years ago, during the late Eocene, the planet began to cool. Antarctica's lush forests began to die back as global temperatures dropped and ice crept inland. Tundra replaced woodland, holding on until about 12 million years ago. The Antarctic Peninsula was among the last holdouts, transitioning from tundra to full glaciation by the Middle Miocene around 13 million years ago. Geological records from the Andril project show that even the Ross Ice Shelf, the largest floating ice body on Earth, has pulsed in size over millennia. During warmer epochs, vast portions of the shelf melted away, revealing open seas teeming with diatoms, microscopic algae that fed ancient marine ecosystems. These cycles of collapse and regrowth offer vital clues for our present and future. Today, as global temperatures rise, these buried histories become urgent warnings. Fossil evidence shows that ice shelves once vanished when the Earth was just 2 to 3 degrees Celsius warmer than now. What happened then may soon happen again. Yet in the face of loss, one truth remains: life endures. From the forests of the Cretaceous to the microbes beneath the ice, Antarctica tells a story not just of extinction and glaciation, but of adaptation, survival, and resilience. It whispers of a time when rainforests swayed under midnight suns and hints at the secrets still locked deep below, waiting to be heard. Dinosaurs of the ice continent. Antarctica's most famous dinosaur, Cryolophosaurus ellioti, was discovered near Beardmore Glacier on Mount Kirkpatrick during the 1990-91 field season. Nicknamed Elvasaurus for its flamboyant crest, this 6.5-meter-long predator roamed the polar forests around 200 million years ago. It was the apex predator of its ecosystem during the early Jurassic, showing that large carnivores could thrive even in cooler, darker climates. Alongside it, scientists discovered Cryolophosaurus hammeri, a large herbivorous sauropodomorph. Dating to around 190 million years ago, it highlights the coexistence of predator and prey in temperate Antarctic woodlands. These finds prove that early ecosystems were complex, supporting diverse dinosaur communities. Later, during the late Cretaceous, 85 to 66 million years ago, smaller herbivorous dinosaurs like Tyrannosaurus antimartensis emerged. Agile and likely adapted to forage in dense underbrush, Tyrannosaurus represents a lineage of ornithopods that could have survived seasonal darkness through behavioral adaptations such as migration or metabolic slowdowns. Another remarkable discovery was Antarctopelta oliveroi, the first dinosaur formally named from Antarctica, found on James Ross Island in 1986. This ankylosaur was a heavily armored herbivore that lived between 71 and 67 million years ago. It likely used its tail as a defensive club and fed on low-lying vegetation in the polar forests. The presence of such a dinosaur, more commonly associated with temperate environments, demonstrates the evolutionary flexibility of Mesozoic life. Fossilized plant material found alongside these dinosaur remains, including southern beech, Nothofagus, supports the idea of lush forest ecosystems near the poles, providing ample sustenance for large herbivores. Even sauropods like titanosaurs left their mark here, suggesting Antarctica once served as a land bridge, allowing migration across Gondwana before continental drift isolated it. Life beneath the ice and lessons for the future. Today, while dinosaurs are long gone, life in Antarctica continues in astonishing forms. Beneath its icy surface lie subglacial lakes like Vostok and Mercer, where microbial life survives without sunlight by feeding on minerals through chemosynthesis. Life forms that resemble what scientists might expect to find on distant icy moons like Europa. Antarctica's climate began to cool drastically around 35 million years ago. Forests retreated, tundra took hold, and glaciation spread across the continent. By the Middle Miocene, 13 million years ago, even the Antarctic Peninsula, the last bastion of vegetation, succumbed to the ice. Geological records from projects like Andril reveal that the Ross Ice Shelf has expanded and contracted multiple times due to global climate fluctuations, exposing nutrient-rich waters teeming with microscopic life during warmer periods. These cycles of warming and cooling hold critical insights for the modern world. The fossil record shows that episodes of ice shelf collapse occurred when global temperatures were just 2 to 3 degrees Celsius warmer than today. As our planet warms once again, the past becomes a roadmap to the future. Unearthing the past, shaping the future. Despite the challenges, sub-zero temperatures, ice-covered terrain, and limited rock exposure, Antarctic paleontology continues to push forward. Each discovery, from a dinosaur fossil to a strand of pollen, deepens our understanding of how life once flourished near the South Pole and how it adapted to dramatic environmental shifts. Antarctica's dinosaurs are more than prehistoric curiosities. They are a testament to the resilience of life and a reminder that even the most barren landscapes can hold rich, forgotten worlds beneath the surface. As the ice recedes and new evidence emerges, we are not just uncovering the past, we are preparing for what lies ahead. Antarctica's climate and ecosystems during the Eocene, from forests to ice. Around 50 million years ago, during the Eocene epoch, Antarctica was a warm, temperate land covered in dense forests. Beech trees, Nothofagus, conifers, and flowering plants thrived across its valleys and coasts. Rivers meandered through the landscape, supporting diverse wildlife, including early penguins and marsupials. Fossilized pollen and plant remains from this period reveal ecosystems with mild summers and dark, but not severely cold winters. This thriving environment began to change as global climates cooled. Tectonic shifts opened the Drake Passage and Tasman Gateway, triggering the formation of the Antarctic Circumpolar Current, ACC, a powerful ocean current that thermally isolated the continent by blocking warm waters from the equator. Volcanic activity and increased weathering from tectonic uplift also contributed to a global drop in atmospheric CO2, accelerating the cooling trend. Fossil evidence captures this gradual transformation. Roots frozen in permafrost show where forests once stood as cold conditions spread from Antarctica's interior. Pollen trapped in sediment layers records the continent's final blooming seasons. Fossilized marsupial teeth containing traces of plant material indicate that these mammals were among the last land vertebrates before extinction or migration. By 34 million years ago, in the early Oligocene, ice sheets had overtaken much of the continent. A brief persistence of tundra along the coasts gave way to full glaciation by 15 million years ago. Today, only microbial life survives in subglacial lakes beneath Antarctica's vast ice sheets. The Eocene fossil record offers a window into Earth's climatic past, revealing how ecosystems respond to rapid environmental shifts. It underscores the complex interplay between tectonics, ocean currents, and carbon cycles, helping scientists model future climate scenarios as modern CO2 levels continue to rise. Why it matters today. The story of ancient Antarctica is not a relic, it is a revelation. CO2 levels that once nurtured polar forests now threaten to awaken them. During the mid-Cretaceous, global CO2 levels reached over 1,000 ppm. Today, they hover above 420 ppm and are rising. Glaciers are melting. The West Antarctic ice sheet is destabilizing. If its past teaches us anything, it is that ice sheets can collapse swiftly once a threshold is crossed. Antarctica's sediment cores show how fast change can come. In mere millennia, pollen-rich layers give way to barren mud. Just as coral reefs bleach in decades, whole continents can transition from forest to freezer in a geological blink. Yet even Antarctica, in its frozen silence, speaks of resilience. After the Great Dying, life returned. After the forests froze, microbes remained. Life finds refuge in cracks, heat, and darkness. Marsupials that once lived in Antarctica migrated to Australia and gave rise to one of the world's most unique ecosystems. Fossil records remind us that survival is possible, but it comes at a cost. Today, we stand at our own tipping point. As climate change accelerates, ancient Antarctica offers both a warning and a guide. It tells us how fast paradise can fall, and how vital it is to listen to the whispers beneath the ice before the jungle is lost forever. It's the end of the story today. Thank you for watching. Subscribe for more deep dives into the forgotten worlds of Earth. Turn on the bell so you never miss a journey back in time.